Have you ever imagined a future where cosmic phenomena don't just inspire awe but actively transform the way we live, work, and connect with the universe? From breathtaking solar flares lighting up our skies like never before to groundbreaking missions unlocking secrets of distant planets, the cosmos is about to reshape our world in ways we can hardly fathom. This isn't just about space exploration. It's about how these events will redefine technology, energy, and even the way we view our place in the vast expanse of the universe. In this video, we're diving into 25 extraordinary cosmic events predicted to happen soon, events that will bridge the gap between science fiction and reality, creating a future where cosmic wonders become part of our daily lives. Get ready to explore how these fascinating developments will not only expand our knowledge of the cosmos, but also revolutionize our lifestyles here on Earth. So buckle up, we're embarking on a journey to uncover the extraordinary possibilities waiting just beyond our horizon. Now turning to the first extraordinary event, let's dive into the phenomenon of the solar maximum, expected to reach its peak around the year 2025. For those unfamiliar, a solar maximum is the period in the Sun's 11-year cycle when its activity is at its most intense. During this time, solar flares and geomagnetic storms become more frequent and powerful, creating both mesmerizing and potentially disruptive effects. One of the most captivating outcomes of a solar maximum is the dramatic increase in auroras, those breathtaking displays of colorful lights dancing across the night sky. Imagine the aurora borealis and aurora australis illuminating regions far beyond their usual visibility, offering once-in-a-lifetime views to people in areas that might never have experienced them before. But while these natural light shows are awe-inspiring, the heightened solar activity also brings significant challenges. Powerful solar flares can interfere with satellite communication, disrupt global positioning systems, and even pose risks to power grids. For our modern, technology-driven lifestyles, this could mean interruptions to everything from navigation systems to internet connectivity. Scientists and engineers are already working on strategies to mitigate these impacts, such as developing more resilient satellites and improving space weather forecasting. However, this period also serves as a reminder of our delicate relationship with the cosmos and how reliant we are on technology vulnerable to space weather. As the solar maximum approaches, it's not just an astronomical event, it's a glimpse into the intricate connection between cosmic phenomena and our daily lives. And with that, let's explore the next trailblazing moment reshaping our view of the universe. As the next chapter in our journey unfolds, let's delve into the incredible advancements brought forth by the James Webb Space Telescope. This revolutionary observatory is not just a marvel of engineering but a gateway to unlocking the deepest mysteries of our universe. Equipped with cutting-edge technology, the telescope is already sending back data that is rewriting what we know about space. One of its most groundbreaking capabilities lies in analyzing the atmospheres of exoplanets, those distant worlds orbiting stars beyond our solar system. By detecting the chemical fingerprints of elements like water, methane, and even oxygen, it brings us closer to answering one of humanity's oldest questions: are we alone in the universe? But the telescope's mission goes far beyond exoplanets. It is also peering into the first few 100 million years after the Big Bang, capturing light that allows scientists to study the formation of the very first stars and galaxies. The discoveries from this data are not just academic, they ripple into real-world advancements. For example, understanding how stars generate energy could inspire breakthroughs in clean energy solutions here on Earth, potentially fueling innovations like space-based solar power systems. Imagine harvesting solar energy directly in space and transmitting it to Earth, providing a sustainable and limitless energy source. The James Webb Space Telescope is not just an instrument, it is a symbol of how far technology can propel us and how much more there is to discover. With every image and dataset it delivers, we stand on the brink of new possibilities, forever changing our perspective on the cosmos and our place within it. Moving ahead, let's explore a cosmic phenomenon that reminds us of the dynamic and evolving nature of space itself. With the next phase of our cosmic exploration upon us, let us turn our focus to a phenomenon that underscores both the beauty and unpredictability of our universe: asteroid close encounters. These near-Earth objects, while awe-inspiring, remind us just how dynamic and ever-changing our cosmic neighborhood is. Among the most anticipated encounters is the asteroid known as Apophis, set to make a remarkably close approach to Earth in the year 2029. Measuring over 1,000 feet in diameter, Apophis will pass so near that it will come closer to us than some of our satellites that orbit the planet. Events like these are not just thrilling spectacles for astronomers, they also serve as critical opportunities for preparing Earth against potential asteroid threats. Tracking these objects requires sophisticated technologies, combining ground-based observatories with advanced radar systems to calculate their trajectories with stunning precision. Agencies like NASA and international space organizations are leveraging artificial intelligence to monitor thousands of asteroids, ensuring we have ample warning if any pose a risk. But monitoring alone is not enough. Scientists are pushing the boundaries of innovation with asteroid deflection methods. One groundbreaking example is the recent success of a mission known as the Double Asteroid Redirection Test, where a spacecraft intentionally collided with an asteroid to alter its orbit. This historic achievement demonstrates that we are not just passive observers of these celestial events, but active participants in safeguarding our planet. Apart from the potential dangers, asteroid encounters also offer valuable scientific insights. These rocky travelers carry materials that date back to the very formation of the solar system, offering clues about the origins of planets and even life itself. Mining these asteroids could open the door to accessing rare metals and resources, potentially revolutionizing industries here on Earth and fueling further space exploration. From understanding our past to securing our future, these cosmic encounters are a testament to the ingenuity and resilience of humanity. Now, as we continue our journey, let us explore a groundbreaking effort that aims to harness the Moon's untapped potential. As the journey brings us closer to the Moon, let's uncover an extraordinary endeavor that could redefine our relationship with Earth's celestial neighbor, Lunar Mining Projects. Imagine a future where the Moon becomes a hub of innovation and resources, a key player in solving some of Earth's biggest challenges. Leading the charge are private companies and space agencies racing to tap into the Moon's untapped wealth. At the heart of this vision lies helium-3, a rare isotope found in lunar soil. Unlike traditional fuels, helium-3 holds the potential to power fusion reactors, offering a clean, virtually limitless energy source. If successfully harnessed, this could not only revolutionize energy production on Earth, but also bring about a profound shift in how we live, work, and thrive in the decades ahead. But the significance of lunar mining extends beyond energy. The extraction of resources like water ice, critical metals, and silicon could create the foundation for sustainable space infrastructure. Water ice, for instance, can be converted into oxygen and hydrogen, essential for life support systems and rocket fuel. This could significantly reduce the cost of deep space exploration, enabling humanity to venture further than ever before. The vision is bold. A thriving lunar economy where mining fuels both Earth-based industries and the expansion of human presence in the cosmos. What makes this pursuit even more fascinating is the sheer ingenuity driving the technologies involved. Robotic miners, autonomous exploration rovers, and advanced processing units are just some of the game changers paving the way for this lunar revolution. Companies like Astrobotic and space agencies, including NASA, are already testing these cutting-edge technologies, with upcoming missions aimed at extracting and analyzing lunar samples. If successful, these initiatives could mark the dawn of an entirely new era of space exploration and economic possibilities. However, such an ambitious undertaking comes with its share of challenges. The harsh environment of the Moon, with its extreme temperatures, radiation, and lack of atmosphere, demands technological innovations that can sustain operations over time. Additionally, the ethical and legal questions surrounding lunar resource exploitation continue to spark debates. Who truly owns the Moon's resources, and how can we ensure they are used responsibly and equitably? These questions remind us of the importance of balancing progress with accountability. The concept of lunar mining may sound like a dream of science fiction, but the strides being made today suggest otherwise. From powering Earth with clean energy to supporting life beyond our home planet, these advancements symbolize the boundless potential of human ingenuity. As we move forward, our gaze turns to another ambitious horizon, Mars, and the vision of humanity establishing a foothold on the red planet. With the next phase of the journey in sight, we set our focus on an audacious vision that could redefine humanity's place in the cosmos: SpaceX's Mars Mission Milestones. At the forefront of this endeavor is Elon Musk, whose dream of establishing a self-sustaining civilization on the red planet is rapidly transforming from concept to reality. The plan is nothing short of extraordinary, aiming to create an interplanetary lifestyle that once existed only in the realm of science fiction. SpaceX's Starship, a fully reusable spacecraft designed to carry both crew and cargo, stands as the centerpiece of this mission. Its monumental goal, to enable the transport of millions of tons of materials and thousands of people to Mars, paving the way for a thriving human settlement. One of the key milestones in this journey is the series of upcoming Starship test launches. These are critical not only for perfecting the technology, but also for demonstrating the feasibility of long-duration space travel. Each flight brings us closer to the day when humans will embark on this daring interplanetary voyage. Beyond the launches, SpaceX is also hard at work developing Mars-based prototypes, envisioned as the foundation for future colonies. These bases would include habitats, greenhouses, and life support systems, all designed to withstand the harsh Martian environment while fostering a sustainable human presence. What makes this vision even more compelling is Musk's belief that life on Mars could one day resemble the bustling communities we see on Earth, equipped with residential areas, workplaces, and even entertainment hubs. The challenges, of course, are colossal. Mars presents extreme conditions, from bone-chilling temperatures to high radiation levels and a thin carbon dioxide-rich atmosphere. Yet, SpaceX's engineers and scientists are innovating at an unprecedented pace to tackle these obstacles. For instance, technologies like oxygen generation from carbon dioxide and resource utilization to create water and rocket fuel directly on Mars are being developed. These breakthroughs are not just about survival, they are about enabling humanity to thrive in entirely new ways. The implications of such progress are profound. A thriving Mars colony could act as a safety net for humanity, ensuring our survival in the face of potential global catastrophes. Moreover, the technological advancements from this mission could revolutionize industries on Earth, from sustainable energy solutions to advanced manufacturing techniques. SpaceX's Mars ambitions also stir philosophical questions. What does it mean for humans to become a multiplanetary species? How will our cultures, societies, and ways of life evolve when Earth is no longer our sole home? These are questions that excite the imagination and challenge us to think beyond traditional boundaries. As we continue to unlock the mysteries of Mars and push the limits of what is possible, our gaze shifts toward yet another game-changing frontier: the burgeoning space tourism industry that promises to bring space closer to us all. Now turning to the thrilling new frontier of space tourism, we step into an era where the dream of traveling beyond our planet is no longer limited to astronauts or science fiction. Companies like Blue Origin and Virgin Galactic are leading the charge, making space travel more accessible to ordinary people, at least those with a significant budget. Blue Origin, founded by Jeff Bezos, has already taken passengers on short but breathtaking journeys to the edge of space. These suborbital flights offer a weightless experience and a view of Earth that has left participants profoundly moved. Imagine looking down at our planet, a glowing blue and green sphere, fragile and magnificent against the vast blackness of space. It is no wonder many describe the experience as life-changing. Virgin Galactic, led by Richard Branson, is also revolutionizing the industry. With their uniquely designed spacecraft, they aim to make spaceflights a cornerstone of luxury adventure. From sleek spaceports offering first-class amenities to the promise of a smooth ride to the upper atmosphere, Virgin Galactic combines high-tech innovation with high-end comfort. Their vision extends beyond suborbital trips, dreaming of a future where longer stays in space are within reach. This new wave of space tourism is quickly shaping itself as the ultimate status symbol, a blend of cutting-edge technology and five-star extravagance. These advancements are not just for show, they symbolize humanity's growing connection to the cosmos. As this industry expands, we may see an entirely new category of experiences emerge, from orbital hotels to moon vacations. This growing accessibility to space travel could redefine high-tech luxury lifestyles. Picture a future where elite vacations include sipping coffee while floating in zero gravity or enjoying a panoramic view of the moon from your suite. The idea of space as a playground for human imagination and innovation feels closer than ever before, yet this transformation extends beyond luxury. Space tourism is also a catalyst for inspiring people to think about our planet differently. Experiencing the vastness of space and the fragility of Earth can spark a profound sense of responsibility toward our world. Many space tourists return with a renewed commitment to sustainability and a deeper appreciation for our shared home. As the competition intensifies among these companies, technologies will continue to evolve, potentially making space travel more affordable over time. This raises possibilities that one day, space exploration could eventually become as common as air travel is today. With such exciting progress, this burgeoning industry is not only opening doors for pioneering tourism, but also accelerating innovations that could benefit countless other sectors. But space tourism is just one piece of the puzzle. While some are looking skyward for exploration and adventure, others are working on protecting the space environment itself. Next, we delve into the critical global effort to combat space debris and the innovative technologies being developed to tackle this invisible yet urgent challenge. As the next challenge unfolds, we look to an issue that is both invisible to most of us and yet critically urgent: space debris. Over the decades, countless satellites, rocket fragments, and even tiny flecks of paint have accumulated in Earth's orbit, creating a growing hazard to active spacecraft and future missions. This accumulating debris, often referred to as space junk, can travel at speeds of thousands of miles per hour, making even the smallest pieces capable of causing catastrophic damage to satellites, space stations, or exploratory missions. But fear not, scientists, engineers, and governments around the world are stepping up with innovative solutions to tackle this daunting problem. One remarkable approach involves the use of laser systems, a technology straight out of science fiction. These systems aim to track and safely nudge smaller debris pieces out of orbit by applying just enough energy to alter their trajectory, causing them to burn up upon re-entry into Earth's atmosphere. Imagine giant telescopes equipped with powerful lasers, silently working from the ground to clear the heavens above. It is an elegant solution for an otherwise chaotic situation. Another groundbreaking innovation is the development of Harpoon satellites. These specialized spacecraft are designed to capture larger pieces of space junk with precision. Imagine a high-tech harpoon shooting out to latch onto a defunct satellite, then dragging it into a controlled descent to safely dispose of it. These efforts are more than just technological marvels. They are essential steps toward ensuring the safety and sustainability of all future space activities. This is not a mission for a single nation or organization. Global cooperation is key, as space debris poses a shared risk for all countries and companies involved in space exploration. Organizations like the European Space Agency and private companies are pioneering these cleanup efforts, while international treaties and policies aim to set guidelines for responsible behavior in orbit. Without such collaboration, the growing debris problem could lead to what scientists call the Kessler syndrome, where a cascade of collisions could render entire regions of orbit unusable for generations. Cleaning up Earth's orbit goes beyond merely protecting our current satellites and space missions. It is about securing the future of space exploration and the technologies we rely on daily, from weather forecasting to global communications. As we send more satellites into orbit for revolutionary projects like worldwide internet coverage and advanced Earth monitoring, the need for a clean and navigable orbital environment becomes more important than ever. The task at hand is daunting but not insurmountable. These combined efforts symbolize humanity's resourcefulness and its determination to solve even the most complex global issues. With such promising innovations underway, the dream of a sustainable, debris-free orbit might just be within reach. And while we focus on cleaning up the skies, another sense of discovery continues to inspire us. Up next, we dive into the search for life beyond Earth and the incredible missions that might finally answer humanity's oldest question: are we alone? As the next phase of our journey unfolds, humanity's most profound question takes center stage: are we alone in the universe? This quest to uncover extraterrestrial life is no longer confined to science fiction, but has evolved into a cornerstone of modern scientific exploration. Right now, groundbreaking missions are setting their sights on some of the most promising destinations in our solar system and beyond, with advancements in technology bringing us tantalizingly close to potential answers. Let's start with Europa, one of Jupiter's icy moons, where a vast ocean of liquid water lies beneath its frozen surface. The upcoming Europa Clipper mission is designed to investigate this hidden ocean, searching for signs of life in an environment that could closely resemble Earth's deep-sea hydrothermal vents, where life thrives in the absence of sunlight. Imagine the implications of finding even microscopic organisms there. It would fundamentally alter our understanding of biology and life's resilience in extreme conditions. Then there's Enceladus, Saturn's enigmatic moon, with its spectacular geysers ejecting plumes of water vapor and organic molecules into space. These plumes provide a direct opportunity to study its subsurface ocean, and future probes aim to fly through them, capturing samples to hunt for biosignatures. Enceladus has quickly become one of the most exciting locations in the search for life, as its chemical and physical conditions hint at the possibility of habitability. If we were to detect even the faintest traces of life, it would open up a whole new chapter in exploring not just how life begins, but where it can exist. But the pursuit doesn't stop within our solar system. Beyond it lies a growing catalog of exoplanets, worlds orbiting distant stars, many of which reside in the so-called habitable zone, a region where conditions might allow liquid water to exist. Cutting-edge observatories like the James Webb Space Telescope are designed to analyze the atmospheres of these planets, searching for potential markers of life, such as oxygen and methane, coexisting in ways that hint at biological activity. Picture a planet hundreds of light-years away emitting signals that suggest the presence of alien ecosystems. Such a discovery would redefine our place in the cosmos, proving that Earth is not an isolated cradle of life but part of a vast, interconnected universe teeming with possibilities. What makes this pursuit even more fascinating is its potential to reshape humanity's worldview. discovering life elsewhere would challenge long-held assumptions about our uniqueness and spark profound philosophical, scientific, and even religious conversations about what it means to coexist in a universe full of life. The ripple effects would extend into culture, technology, and our collective imagination, inspiring an era of exploration fueled by curiosity and wonder. These extraordinary missions, targeting the icy moons of the outer planets and the distant worlds of other star systems, represent an unparalleled moment for science and humanity. Each step brings us closer to answering questions that have inspired us for generations. As we await the results of these endeavors, it is hard not to feel an overwhelming sense of anticipation. What lies beneath Europa's ice, in Enceladus's plumes, or among the stars might just hold the key to unlocking life's ultimate mystery. And speaking of mysteries, up next, we uncover how advancements in nuclear fusion might bring us closer to harnessing the power of artificial stars right here on Earth, shaping the future of energy as we know it. As we pivot to the next groundbreaking development, the vision of harnessing the power of the stars right here on Earth comes into focus. The concept of creating miniature artificial stars, an awe-inspiring leap in nuclear fusion, has captivated scientists and innovators for decades. Unlike traditional energy sources, nuclear fusion replicates the same process that powers the sun, fusing atomic nuclei to release immense amounts of energy without the harmful byproducts like greenhouse gases or long-lived radioactive waste. Recent advancements have brought us tantalizingly close to achieving this futuristic dream, with experimental reactors now surpassing critical milestones. Take, for example, the breakthrough in achieving net energy gain, where a fusion reaction produces more energy than it consumes, a feat long considered the holy grail of energy research. What makes nuclear fusion so revolutionary is not just its immense power potential, but also its sustainability. Fusion relies on isotopes of hydrogen, which are abundantly available in water, making the fuel source virtually inexhaustible. Imagine a future where vast city grids, transportation networks, and even space exploration missions are powered by compact fusion reactors, ensuring a clean and limitless energy supply. This could redefine life in urban centers, enabling everything from ultra-efficient smart cities to dramatic reductions in carbon footprints. Rooftops covered in solar panels or sprawling wind farms might one day give way to sleek, unobtrusive fusion facilities, seamlessly integrated into the urban fabric. Beyond the practical, the cultural implications of mastering nuclear fusion are equally profound. The ability to replicate the core process of the stars not only pushes the boundaries of human ingenuity, but also symbolizes humanity's deep connection to the cosmos. It reinforces the belief that solutions to Earth's most pressing challenges can be found by looking upward and daring to dream beyond our immediate grasp. As these advancements unfold, the promise of nuclear fusion could very well usher in a golden age of energy independence and environmental harmony, offering a glimpse of a future where humanity thrives in balance with the planet. With these artificial stars lighting up possibilities for a sustainable tomorrow, it is clear that the road ahead is as radiant as the fusion-powered cores themselves. And just as we explore the forces shaping energy on Earth, our journey continues to uncover the next cosmic marvel, an awe-inspiring total solar eclipse that will soon have the world looking skyward in shared wonder. As the cosmos prepares to unveil its next breathtaking act, the stage is set for a celestial event that has fascinated humanity for centuries: the rare and mesmerizing total solar eclipse. On a day in April 2024, millions of people across parts of North America will witness the sun completely disappear behind the moon, plunging the landscape into an otherworldly twilight. This brief yet unforgettable spectacle, where the moon's shadow sweeps across the Earth, will leave viewers in awe as day turns to night in a matter of moments. Total solar eclipses are more than just astronomical events. They are experiences that connect us to the mysteries of the universe in a profoundly personal way. Throughout history, eclipses have inspired countless myths, shaped ancient cultures, and even influenced scientific breakthroughs. For instance, a total solar eclipse in 1919 provided the opportunity to test Albert Einstein's theory of general relativity, confirming the way massive objects bend the fabric of space-time. Yet, beyond the scientific and historical significance, eclipses remind us of the delicate precision of our solar system. The fact that the sun and moon appear nearly the same size in the sky despite being vastly different in actual size and distance is a cosmic coincidence that allows us to marvel at this phenomenon. To fully savor this awe-inspiring event, preparation is key. Finding yourself in the path of totality, the narrow strip of Earth where the moon will completely cover the sun, is essential to experiencing the full majesty of the eclipse. Locations like Texas, Arkansas, and parts of New York are expected to provide some of the best views. Make sure to protect your eyes with specially designed solar viewing glasses during the partial phases of the eclipse, and have a camera or smartphone ready to capture the dramatic change in light and shadow, although no photo or video can truly capture the emotion of witnessing it in person. For those who experience it, a total solar eclipse often becomes more than just an item on a bucket list. It's a moment that stays with you forever. The cheers of the crowd, the sudden chill in the air, the corona of the sun shimmering like a crown around the darkened moon, all create an atmosphere of wonder that words fail to describe. And as the moon's shadow continues its journey across the Earth, we're reminded of our shared connection under the same sky. With this celestial event on the horizon, the chance to look skyward in communal awe is a reminder of how vast and extraordinary our universe truly is. As the next chapter unfolds, we journey further to explore the cutting-edge technologies that could one day make this cosmic dance of light and shadow more than a fleeting experience, but an inspiration for new horizons in discovery. As the horizon of cosmic exploration widens, we step into the fascinating realm of warp drive research, a concept that seems to blur the boundaries between science fiction and reality. Warp drives, for those unfamiliar, refer to a theoretical propulsion system that could enable faster-than-light travel by bending the very fabric of space-time itself. Imagine not just traveling across vast cosmic distances, but effectively shortening them by contracting space in front of a spacecraft while expanding it behind. This groundbreaking idea, rooted in Albert Einstein's theory of general relativity, has inspired countless scientific minds and dreamers alike. Recent breakthroughs in theoretical physics bring this once purely speculative concept closer to the realm of possibility. New models propose ways to significantly reduce the massive energy requirements originally thought necessary to create a warp bubble, the mechanism that would allow a spacecraft to travel faster than light without technically breaking the universal speed limit. By exploring innovative approaches such as manipulating exotic forms of matter or leveraging the energy of quantum fields, scientists are beginning to chart a roadmap, however distant, toward practical interstellar travel. The implications of mastering warp drive technology are nothing short of transformative. Such a leap would not only allow humans to reach neighboring star systems like Alpha Centauri within years instead of millennia, but it could also spark an unprecedented era of exploration that redefines our place in the universe. Whole new frontiers of discovery would open, offering possibilities for finding Earth-like planets, uncovering alien life, and expanding human civilization beyond the confines of our solar system. The ripple effects would extend far beyond space exploration, as technologies developed in pursuit of warp travel could revolutionize energy systems, material science, and even our understanding of physical laws. While a functioning warp drive remains decades or perhaps centuries away, the pursuit itself is a testament to humanity's unyielding curiosity and ingenuity. It pushes us to confront the limits of what we know and to envision a future unconstrained by the barriers of distance or time. And as we journey deeper into this cutting-edge research, we are reminded that the line between imagination and reality is often drawn by the boldness of our questions and the persistence of our quest for answers. Moving from theoretical propulsion to the practical concerns of space exploration, let us now explore how emerging technologies are reshaping the potential for sustainable energy and futuristic lifestyles on Earth and beyond. Shifting our focus from the vastness of interstellar travel to a groundbreaking innovation much closer to home, let us delve into the transformative potential of space-based solar power systems. These systems represent a bold leap in clean energy solutions, envisioning a future where we harness the sun's immense energy directly from space. The concept is as brilliant as it is ambitious, placing solar panels in orbit to collect sunlight unobstructed by Earth's atmosphere, and then transmitting that energy back to Earth using advanced wireless technology. Imagine uninterrupted, around-the-clock access to solar power, unaffected by weather conditions or nightfall, fundamentally reshaping how we generate and consume energy. Leading innovators and space agencies around the world are already making strides toward turning this vision into reality. By designing lightweight, efficient solar panels and exploring cutting-edge methods for wireless energy transmission, such as microwave beams or lasers, scientists are working to overcome the engineering challenges of deploying and maintaining these orbital power stations. When perfected, these systems could supply Earth with a virtually limitless source of clean energy, significantly reducing our reliance on fossil fuels and helping combat climate change. The impact of space-based solar power would extend far beyond environmental benefits. It could make energy more accessible to remote and underserved regions, empowering communities worldwide. Furthermore, by integrating this technology with emerging advancements such as electric vehicles and smart cities, we could usher in a futuristic lifestyle where energy flows seamlessly, fueling innovation and sustainability in every aspect of daily life. While the road to fully operational space-based solar power systems is still long, the progress being made today is a testament to humanity's ingenuity and determination. As these technologies continue to advance, they bring us closer to a future where the boundless energy of the cosmos powers our world. With this exciting prospect in mind, let us now turn to another ambitious cosmic endeavor reshaping our technological future: the rise of mega-constellations designed to blanket the Earth with seamless global internet coverage. As we shift our gaze toward the next transformative development in our cosmic journey, let us explore the rise of mega-constellations and their potential to revolutionize global connectivity. Imagine a future where the internet is no longer a luxury but a universally accessible utility, even in the most remote corners of the world. Companies like SpaceX and Amazon are leading this ambitious effort, deploying thousands of satellites into low Earth orbit to create vast networks capable of delivering high-speed internet to virtually every location on the planet. These networks, often referred to as mega-constellations, are designed to close the digital divide and bring seamless communication to underserved and isolated communities. The potential benefits of mega-constellations are staggering. For one, they could empower regions lacking traditional internet infrastructure, opening doors to education, healthcare, and economic opportunities in ways previously unimaginable. Entrepreneurs in rural areas could connect to global markets, students could access online learning resources, and medical professionals could deliver remote care with unprecedented ease. Beyond individual empowerment, these networks promise to bolster industries reliant on real-time data, such as agriculture, logistics, and disaster response, by providing reliable connectivity in areas where traditional networks falter. Yet, as monumental as these advancements are, they come with significant challenges. The sheer number of satellites required to build these networks raises concerns about space congestion and the growing issue of space debris. With thousands of satellites orbiting the Earth, the risk of collisions increases, potentially threatening other critical space operations. Furthermore, astronomers have voiced concerns about the impact of these satellite swarms on stargazing and observational research, as their reflective surfaces can interfere with telescopes studying the night sky. Addressing these issues will require careful planning, innovation, and global cooperation to ensure that progress in one sphere does not hinder advancements in another. Despite these challenges, the rise of mega-constellations marks a pivotal moment in the evolution of communication technology. By integrating these networks with emerging advancements such as artificial intelligence and the Internet of Things, we edge closer to a world where connectivity is as ubiquitous and essential as electricity. The promise of a fully connected planet not only transforms how we communicate but also redefines how we live, learn, and thrive in an increasingly digital age. With this exciting vision in mind, let us now turn our attention to another captivating mystery that could alter our understanding of the universe itself: the ongoing quest to unravel the elusive secrets of dark matter. With the next phase of the journey in sight, we dive into one of the most profound enigmas of modern science: the mystery of dark matter. Dark matter makes up an estimated 85% of the universe's mass, yet it remains entirely invisible, interacting with normal matter only through gravity. Scientists have been striving to uncover its secrets for decades, and upcoming experiments could bring us closer than ever to solving this cosmic puzzle. Facilities like the upgraded Large Hadron Collider and deep underground laboratories are delving into cutting-edge techniques to detect dark matter particles. These efforts range from observing rare particle interactions to recreating conditions resembling the first moments after the Big Bang. Understanding dark matter isn't just about solving a theoretical challenge. It holds transformative potential for the future of physics and technology. For instance, cracking the code of dark matter could lead to breakthroughs in energy storage and transportation systems, taking us far beyond what current technologies allow. Imagine revolutionary advances that power spacecraft with unparalleled efficiency, or reshape urban centers with energy systems drawn straight from the fundamentals of the universe. But that is not all. Dark matter research could redefine our understanding of reality itself, offering insights into the forces that bind galaxies together and perhaps even the nature of time and space. The implications extend into inspiring new ways of thinking about our place in the cosmos. These discoveries could ripple across industries, spurring innovations in computing, material science, and even medical technology by applying new principles derived from dark matter studies to enhance tools and systems used in everyday life. As the scientific community continues its quest to illuminate this invisible force, one thing is certain: the journey to understand dark matter is as thrilling as it is fundamental. Each new experiment and discovery not only brings us closer to answers, but also challenges us to imagine a universe far more complex and interconnected than we ever thought possible. And with this sense of wonder, let us now explore an entirely different yet equally revolutionary frontier: the potential rebirth of supersonic air travel and the ways it could redefine global connectivity in the 21st century. As we lift off into the next fascinating chapter, the skies are calling us back with a vision of the future that once seemed like yesterday's dream: the return of supersonic air travel. Imagine crossing oceans in just a few hours, reconnecting distant corners of the world with a speed and efficiency that were thought to be relics of the past. This rebirth is being fueled by groundbreaking technologies, many inspired by cosmic advancements that are reshaping what is possible in aviation. Companies around the world are now taking bold steps to reintroduce commercial supersonic planes, but this time with a cutting-edge edge. Unlike the supersonic planes of the past, like the Concorde, these new marvels are designed to be not only faster but also far more sustainable. Engineers are leveraging materials and designs derived from space exploration, such as lightweight composites that can withstand extreme forces while reducing fuel consumption. There is even talk of integrating propulsion systems influenced by advanced aerospace research, potentially using engines inspired by scramjet and other space-bound technologies. These innovations are hoped to eliminate or significantly reduce the infamous sonic boom, making supersonic travel more practical and accessible for modern aviation. The implications of this are enormous. Long-haul flights that once took over 12 hours could shrink to under 5, redefining how we think about business, tourism, and even global trade. Imagine attending a meeting across continents in the morning and returning home for dinner, or envision the possibilities for international collaboration when distance becomes nothing more than a minor inconvenience. Supersonic travel could transform the way the world connects, bringing us closer together in ways that could revolutionize global culture and commerce. But there is more to the story. These advancements are not just about speed, they are about creating a new standard of efficiency and luxury. Emerging concepts include quieter cabins, augmented reality interfaces for passengers, and even the use of alternative fuels to minimize environmental impact. These planes could become symbols of a new era of flight, blending futuristic technology with the timeless human aspiration to push boundaries. As the industry gears up for the challenges ahead, from regulatory hurdles to technical refinements, there is an electrifying sense that we are on the brink of a new aviation golden age. And while the skies hold the promise of faster journeys, let us now turn our gaze to an entirely different domain: NASA Artemis program and the monumental effort to return humans to the moon, paving the way for a future that reaches beyond Earth itself. With the next phase of exploration on the horizon, we set our sights on the moon, where humanity is preparing to take one giant leap forward once again. NASA Artemis program is not just about revisiting the lunar surface. It is a bold mission to redefine our relationship with space. The Artemis program aims to land the first woman and the next man on the moon, but it does not stop there. This groundbreaking effort is laying the foundation for a sustainable human presence on the moon, which could revolutionize our future on Earth and beyond. Imagine lunar bases powered by cutting-edge technologies, where research and innovation thrive in ways we cannot even fully comprehend yet. The moon is a treasure trove of possibilities, from its valuable resources like water ice critical for creating breathable air and rocket fuel, to its potential as a launchpad for deeper space exploration. By establishing a permanent lunar presence, humanity could unlock the key to long-term survival in space and dramatically reshape how we think about life beyond Earth. The Artemis program offers more than scientific discovery. It opens doors to futuristic off-world lifestyles that once seemed like pure science fiction. At the heart of this effort are advanced technologies that will enable us to live and work in the harsh lunar environment. From modular habitats designed to endure extreme temperature swings to robust life support systems and innovations like in-situ resource utilization, essentially using local materials to build and sustain structures. The possibilities are vast. Such technologies could pave the way for self-sufficient communities not just on the moon, but also on planets like Mars in the future. But what does this mean for life here on Earth? While space exploration often feels distant from daily life, many of the innovations developed for Artemis could directly benefit us. Think about breakthroughs in renewable energy, advanced robotics, and even medical technologies, all of which could be adapted to solve pressing challenges on our own planet. Additionally, the Artemis program inspires a new generation of thinkers, dreamers, and problem solvers, showing us that by reaching for the stars, we can transform life at home. As momentum builds for human space exploration, this mission is setting the stage for the next chapter of humanity's story, a chapter where the moon becomes a stepping stone to the broader cosmos. And while the Artemis program sparks visions of lunar cities and interplanetary travel, it also reminds us of the boundless potential that comes with curiosity and collaboration. Speaking of collaboration, let us now shift to a cosmic development where scientists are joining forces to unlock even greater celestial mysteries. the next generation of telescopes designed to illuminate the farthest reaches of the universe and beyond. As we venture further into the great expanse of space, a remarkable frontier is emerging: space farming. This might sound like something from a futuristic novel, but it is becoming an essential reality for sustaining long-term human presence beyond Earth. Imagine astronauts growing fresh vegetables and fruits aboard spacecraft or on distant planets, ensuring not just survival but also enhancing the quality of life far from home. This effort is not merely about producing food. It is a critical step toward creating self-sufficient ecosystems that can support humanity's dreams of exploring and living in space. One of the most promising advancements in this field is the development of controlled environments for growing crops in microgravity. Scientists are mastering ways to cultivate plants without soil, using methods like hydroponics and aeroponics, where nutrients are delivered directly through water or mist. These techniques are not only efficient but also remarkably adaptable, allowing crops to thrive in the challenging conditions of space. Picture a small, thriving greenhouse orbiting Earth, where leafy greens and even strawberries flourish under artificial light, proof that life can find a way even in the most alien environments. Beyond providing food, these advancements could transform how we think about ecosystems on Earth. Techniques perfected in space farming are already paving the way for innovations in urban agriculture, vertical farming, and other sustainable food production methods. By learning how to grow crops with minimal resources, we are addressing some of the biggest challenges facing agriculture today, such as water scarcity, soil degradation, and climate unpredictability. The solutions developed for off-world farming could redefine how we feed the growing population here at home. But space farming is not just about practical solutions, it also offers psychological benefits for astronauts on prolonged missions. The simple act of nurturing plants, seeing them grow, and enjoying the fruits of their labor creates a sense of connection to life and Earth that is vital for mental well-being. This connection becomes even more meaningful when imagining life on distant planets, where the ability to grow food could symbolize hope and resilience for humanity. The innovations driving space farming are a testament to human ingenuity, blending biology, engineering, and environmental science in groundbreaking ways. As these technologies evolve, they bring us closer to a future where humanity can thrive not just on Earth, but wherever our journey takes us. Speaking of journeys, let us now focus on another breakthrough that is reshaping our understanding of the cosmos: the next generation of telescopes designed to explore the universe like never before. As the next phase of cosmic discovery unfolds, the spotlight turns to an extraordinary leap in astronomy: the next generation of telescopes. Among these groundbreaking instruments, the Nancy Grace Roman Space Telescope is poised to revolutionize how we explore the universe. This cutting-edge observatory is designed to capture an expansive view of space, uncovering secrets hidden within distant galaxies and expanding our understanding of the cosmos in ways previously unimaginable. What sets the Nancy Grace Roman Space Telescope apart is its remarkable ability to survey vast portions of the sky with incredible precision. Equipped with a massive field of view and advanced imaging technology, it can capture detailed snapshots of more stars and galaxies in a single image than ever before. This telescope will allow astronomers to create a more comprehensive map of the universe, searching for clues about its origins and the mysterious forces driving its expansion, such as dark energy. One of its primary missions is to shed light on the enigma of dark matter and dark energy, two phenomena that make up the majority of the universe yet remain largely unknown. By observing the distribution and behavior of galaxies across immense distances, this telescope will provide critical data to piece together how these unseen forces shape the cosmos. Imagine gaining insights into the invisible threads that hold the universe together, an achievement that could transform our fundamental understanding of physics and existence itself. In addition to exploring these mysteries, the telescope will also play a key role in the search for planets outside our solar system, known as exoplanets. Its high-resolution capabilities will help identify new worlds orbiting distant stars, potentially uncovering planets with conditions suitable for life. Picture the possibility of finding Earth-like planets in nearby systems, sparking fresh hopes for discovering life beyond our world and advancing humanity's quest to understand our place in the universe. The advancements brought by the Nancy Grace Roman Space Telescope will not only amplify our cosmic vision, but also inspire new generations of scientists, engineers, and dreamers. It represents a collective effort to push the boundaries of what is possible, combining the ingenuity of cutting-edge technology with humanity's timeless curiosity. And while this telescope promises to unlock countless wonders, it is just one part of a broader wave of innovation in astronomy. Leading the way into this exciting era of exploration, we now turn our attention toward the accelerating efforts to reach our nearest neighboring star system, Alpha Centauri. With the next phase of the journey in sight, we set our gaze toward the bold ambition of reaching Alpha Centauri, our closest neighboring star system. This monumental goal represents a leap in human ingenuity as scientists and engineers explore groundbreaking technologies like nanoprobes and futuristic spacecraft capable of interstellar travel. Imagine crafts no larger than a postage stamp, propelled by powerful laser beams from Earth, racing across the void of space at a fraction of the speed of light. These incredible innovations could make the dream of interstellar exploration a reality within this century. Alpha Centauri holds particular fascination because it is home to 3 stars, one of which, Proxima Centauri, hosts at least one planet in its habitable zone where conditions might support liquid water. The tantalizing possibility of Earth-like planets just 4 light-years away opens up the prospect of uncovering environments where life could exist. By reaching this system, humanity could gather crucial data about alien worlds, dramatically expanding our understanding of planetary formation, atmospheres, and habitability beyond our solar system. But this mission is about more than scientific discovery. It lays the groundwork for potential cosmic colonization. By exploring Alpha Centauri, we take the first steps toward establishing humanity as an interstellar species. This vision isn't just a theoretical exercise, it's a practical strategy for ensuring the survival of life in the long term, offering a lifeboat for humanity in case Earth faces insurmountable challenges in the future. The efforts to reach Alpha Centauri underscore our drive to push boundaries, fueled by cutting-edge science and unyielding curiosity. These missions symbolize a profound shift in human potential, turning what was once the realm of imagination into tangible exploration. And while the prospect of interstellar travel is dazzling, it exists within a broader constellation of advancements reshaping our understanding of the universe. Moving further into these cosmic breakthroughs, we now delve into the remarkable progress being made in forecasting cosmic weather. As the narrative shifts to another fascinating horizon, we focus now on the groundbreaking advancements in predicting cosmic weather. Cosmic weather, which includes solar storms and energetic particles streaming from the sun, plays a critical role in shaping the conditions not just in space but also on Earth. These solar events can impact satellite communications, disrupt power grids, and even affect astronauts operating in orbit. To safeguard our modern, technology-dependent society, scientists are developing cutting-edge tools to forecast and mitigate the effects of these powerful cosmic phenomena. Imagine being able to predict solar eruptions with the precision of a weather report, allowing us to prepare in advance for any disruptions they might cause. This level of forecasting could be a game-changer for industries and nations alike. One of the most exciting advancements in this field is the concept of magnetosphere shields. These shields could serve as a protective bubble around Earth or even individual spacecraft, deflecting harmful solar radiation and ensuring the safety of systems and humans exposed to cosmic conditions. By creating these dynamic barriers, we could dramatically reduce the impact of solar storms, protecting everything from orbiting satellites to terrestrial power grids. This technology represents a critical leap not only for the sustainability of space exploration, but also for the resilience of infrastructure that billions of people rely on daily. Beyond physical defenses, scientists are also leveraging artificial intelligence to analyze solar activity data and produce real-time predictions. These intelligent systems could help identify patterns and forecast space weather with unparalleled accuracy, offering advanced warnings that allow for preventive measures. For instance, electric utilities could temporarily shut down portions of the grid to avoid massive blackouts caused by solar-induced currents, or space agencies could delay launches to ensure equipment remains unharmed. The implications of these innovations extend far beyond Earth, as we venture further into the cosmos with missions to the Moon, Mars, and beyond. Understanding and preparing for cosmic weather becomes even more vital. These advancements solidify humanity's readiness to navigate the challenges of space, ensuring our efforts remain sustainable and successful in the face of powerful solar dynamics. With these remarkable breakthroughs in mind, we now shift our attention to another transformative force reshaping our exploration of the universe: the role of artificial intelligence in space exploration. As the next chapter of our cosmic journey unfolds, we delve into the transformative role of artificial intelligence in space exploration. Artificial intelligence is not only revolutionizing how we interact with technology on Earth, but it is also becoming an indispensable tool for unraveling the mysteries of the universe. By processing vast amounts of cosmic data at speeds and accuracies that far surpass human capabilities, artificial intelligence is accelerating discoveries that were previously unimaginable. For instance, analyzing data from telescopes, satellites, and space missions often involves sorting through billions of signals to identify meaningful patterns. Artificial intelligence systems excel at this, sifting through the noise to uncover critical insights, whether it is spotting an exoplanet in the habitable zone of a nearby star or detecting subtle variations that hint at the presence of water or organic molecules. One of the most exciting applications of artificial intelligence lies in automating spacecraft missions. Unlike humans, artificial intelligence can operate tirelessly in environments that are hostile, remote, and unpredictable. Imagine a rover on Mars not only navigating the planet's challenging terrain, but also making real-time decisions on which rock formations to analyze, all without waiting for instructions from Earth. These intelligent systems empower space probes and landers to explore autonomously, maximizing the scientific return of each mission while minimizing delays and risks. This capability is particularly critical for missions venturing deeper into our solar system or beyond, where communication delays can stretch to hours or even days. Artificial intelligence is also reshaping the way we prepare for and execute space missions. Virtual simulations powered by artificial intelligence allow researchers to test countless mission scenarios and identify the most optimal strategies. This means less trial and error, reduced costs, and improved success rates for complex undertakings, from deploying satellites to building lunar bases. Additionally, artificial intelligence-driven robots are set to play a major role in constructing habitats for human explorers, from assembling modular structures on the Moon to mining resources on Mars. The implications of artificial intelligence in space exploration extend to decision-making on Earth as well. By combining artificial intelligence insights with human expertise, scientists and engineers can tackle challenges more effectively, whether it involves designing more efficient spacecraft or studying how space conditions influence biological systems. Furthermore, these innovations have a ripple effect, driving advancements in artificial intelligence technologies that benefit industries on Earth, from healthcare to agriculture. As humanity pushes the boundaries of exploration, artificial intelligence stands as a beacon of possibility, bridging the gap between our ambitions and the immense challenges of the cosmos. With its ability to analyze, automate, and innovate, artificial intelligence is not just a tool. It is a partner in our quest to understand and inhabit the universe. And speaking of reshaping how we approach the great unknown, let us now turn to another groundbreaking technology that promises to transform how we construct and sustain life in space: the advancement of three-dimensional printing in space. As we venture into the next groundbreaking innovation, the advancement of three-dimensional printing in space takes center stage. This technology is not just a tool, it is a game-changer, reshaping how we build, repair, and sustain in the most unforgiving environments of the cosmos. Imagine a future where spacecraft components, habitats, and even tools can be produced on demand, right where they are needed, eliminating the need to launch countless supplies from Earth. This is the promise of three-dimensional printing in space, a technology that is already proving its worth aboard the International Space Station. Astronauts have successfully used three-dimensional printers to fabricate tools and parts, showcasing their potential to address emergencies and reduce dependence on resupply missions. Now, picture this capability scaled up for interplanetary missions or the construction of lunar bases. By using materials sourced from the Moon's surface itself, such as lunar regolith, three-dimensional printing could allow for the creation of entire structures, from protective domes to living quarters, directly on-site. This would not only save enormous costs but also enable sustainable living in environments where traditional construction is impossible. Beyond construction, three-dimensional printing extends to creating intricate components for spacecraft, designed with precision and efficiency that traditional manufacturing methods simply cannot match. This opens new doors for customized designs tailored to the specific needs of each mission, from lightweight parts that conserve fuel to uniquely shaped components that optimize space and functionality. The flexibility and adaptability offered by three-dimensional printing could drastically transform the way we approach spacecraft design and mission planning. The implications for Earth are equally exciting. Advancements in space-based three-dimensional printing are inspiring innovations in industries back home, from healthcare to architecture. For instance, the principles being developed for printing habitats in space are being adapted to create affordable housing solutions on Earth, addressing global challenges like urban overcrowding and disaster relief. Additionally, the need for reusable and sustainable materials in space is driving eco-friendly approaches that are finding applications in manufacturing processes on Earth, further promoting a circular economy. As humanity prepares for a future that extends far beyond our planet, three-dimensional printing stands as a cornerstone of this transformation. By enabling us to build almost anything, anywhere, it bridges the gap between the limitations of our current technology and the boundless possibilities of life in space. And speaking of boundary-pushing ideas, our cosmic journey continues with an exploration of an intriguing phenomenon that is expanding our understanding of the universe: the search for new gravitational waves. With the next phase of our cosmic journey in sight, we delve into the fascinating search for new gravitational waves, a pursuit that is redefining how we perceive the universe. Gravitational waves are ripples in the very fabric of space and time, created by some of the most dramatic cosmic events imaginable, such as the collision of black holes or the merging of neutron stars. These waves carry with them stories from billions of years ago, acting as messengers from the farthest reaches of the cosmos. The ability to detect and study these waves is one of the most groundbreaking achievements of modern science, made possible by incredibly advanced detectors that push the limits of technology and ingenuity. Instruments such as the Laser Interferometer Gravitational Wave Observatory and the Virgo Interferometer can detect distortions in space-time so minuscule that they measure less than the width of a proton, yet these tiny signals hold immense scientific value. Each new gravitational wave detected unlocks a piece of the cosmic puzzle, giving us insight into phenomena that were once purely theoretical. For example, the first detection of gravitational waves in recent years confirmed the existence of black hole mergers, providing direct evidence of these powerful collisions. Beyond that, these detections allow us to measure the masses, speeds, and even spins of the colliding objects, shedding light on how they formed and evolved over time. The merging of neutron stars, on the other hand, has illuminated the origins of heavy elements like gold and platinum, giving us a deeper understanding of how the materials that make up our own world were forged in the hearts of cataclysmic events. The implications of this research extend far beyond tracking cosmic collisions. Gravitational waves open up an entirely new way of observing the universe, unlike traditional methods that rely on light. This means we can now listen to the universe in addition to seeing it, uncovering hidden phenomena that optical telescopes could never detect. As the technology improves, the sensitivity of these detectors is increasing, enabling them to pick up signals from even more distant and faint sources. Scientists anticipate that future gravitational wave observatories, both on Earth and in space, will allow us to explore even deeper into the history of the universe, potentially revealing secrets about its very inception. This new way of observing the cosmos is not just a technical marvel but a philosophical shift. It forces us to rethink our place in the universe and the interconnectedness of everything within it. By studying gravitational waves, we are not merely uncovering the mechanics of distant celestial events, but also expanding our understanding of the fundamental nature of reality itself. It is a poignant reminder of how, through perseverance and innovation, humanity continues to push beyond boundaries once thought insurmountable. And just as these ripples in space-time reveal the interconnected dance of the cosmos, our next exploration involves a similarly interconnected effort that is reshaping the future. Let us turn to the rapid expansion of private space organizations and their astounding contributions to space exploration. As humanity ventures further into the cosmos, the growing influence of private space organizations marks a transformative era in space exploration. Companies like SpaceX, Blue Origin, and Rocket Lab are not only competing with traditional government-led agencies, but are also speeding up the pace of innovation with bold approaches, reducing costs, and introducing cutting-edge technologies. By developing reusable rockets and efficient spacecraft, these organizations are making space more accessible than ever before, a feat that was once considered unattainable. Their efforts are not just focused on grand interplanetary ambitions, but are also revolutionizing life on Earth by laying the foundation for a new economy driven by space-based technologies. The economic impact of this rapid expansion cannot be overstated. By enabling affordable satellite launches, private companies are fueling advancements in global connectivity, agriculture, and disaster management. Imagine a world where high-speed internet reaches the most remote villages, where farmers rely on satellite imagery to improve crop yields, and where early warning systems accurately predict natural disasters, saving countless lives. These are not distant dreams, but realities unfolding right now, powered by the development of mega constellations and other satellite networks launched by private players. As these technologies mature, they promise to bridge gaps in communication and resource accessibility, creating a more connected and equitable world. The influence of private space organizations extends beyond Earth's orbit as well. Projects like lunar mining and asteroid exploration are becoming plausible, driven by the innovative spirit and financial flexibility of these corporations. The extraction of rare resources from celestial bodies could unlock new possibilities in manufacturing, energy production, and even medicine, reshaping industries on an unprecedented scale. Moreover, this commercialization of space is inspiring a new generation of engineers, scientists, and entrepreneurs to pursue careers in the aerospace sector, fostering a wave of technological innovation that benefits society at large. But the contributions of private space organizations go beyond mere technology and profit. They are igniting a collective imagination about what is possible. By pushing boundaries with missions to Mars, ambitious space tourism ventures, and collaborations to build lunar bases, these companies are making space exploration a global, shared aspiration. Their bold visions are stirring excitement not only among scientists but also the general public, broadening our understanding of humanity's potential. As more players enter the field, healthy competition is driving down costs and increasing opportunities for collaboration, paving the way for a future where space is no longer the realm of a select few but a frontier open to all. This synergy of economic potential, technological innovation, and shared ambition has the power to transform life as we know it. By blending entrepreneurial ingenuity with human curiosity, private space organizations are not just exploring the cosmos, they are reshaping the way we think about progress and possibility. And as this new era unfolds, it sets the stage for the ultimate exploration of cosmic energy on a truly massive scale. Let us now turn to the intriguing concept of space megastructures and the revolutionary ideas they bring to the table. With the next phase of the journey in sight, let us delve into the fascinating world of space megastructures, grandiose, almost mythical concepts that, while speculative, hold the promise of transforming humanity's relationship with energy and survival in the cosmos. One of the most awe-inspiring ideas is the concept of the Dyson sphere, a hypothetical structure that could encircle a star to capture its immense energy output. Imagine harnessing the total power of the sun, providing humanity with virtually infinite clean energy to not only sustain life on Earth, but also power advanced technologies and future space colonies. While we're still far from building anything close to this magnitude, the preliminary steps are already being taken. For instance, advancements in solar energy collection, space-based solar power systems, and modular construction in space are laying the groundwork for such revolutionary energy solutions. The Dyson sphere is a testament to humanity's boundless ambition, inspiring researchers and engineers to think beyond planetary limitations. Another captivating concept is the proposal for orbital rings, massive structures that could encircle Earth, providing a stationary platform for launching spacecraft or even housing futuristic cities in space. These rings could utilize advanced materials and magnetic systems to make low-cost, energy-efficient space travel a reality. Their potential extends beyond transportation. They could also support satellites, clean energy infrastructure, and even serve as a stepping stone for interstellar exploration. While these structures remain theoretical, rapid advancements in material science and robotics are slowly nudging them toward the realm of feasibility. These megastructures, though seemingly pulled from the pages of science fiction, spark our imagination and push the boundaries of what we believe is possible. They challenge humanity to think on a cosmic scale, envisioning not just survival but thriving on the vast resources the universe has to offer. While the path to realizing structures like Dyson spheres or orbital rings is undoubtedly long and fraught with challenges, their mere conception propels innovation and fuels the optimism needed to address the energy and resource demands of an ever-evolving civilization. By daring to imagine such colossal achievements, we reaffirm our place as explorers of not just Earth, but the cosmos itself, where the only true limit is the scope of our collective vision. As we come to the end of this cosmic journey, let's take a moment to reflect on the incredible events and ideas we've explored together. From the fiery brilliance of the solar maximum to the mind-bending possibilities of warp drive research, each of these milestones reveals a future where humanity dares to push beyond its limits. The launch of the James Webb Space Telescope, the Artemis missions to the Moon, and the quest for extraterrestrial life remind us that our curiosity is as infinite as the universe itself. These advancements are more than scientific feats. They are profound steps forward in understanding our place in the cosmos and ensuring a sustainable future for generations to come. Imagine living in a world powered by space-based solar energy, traveling across the stars with the help of warp drives, or witnessing the unveiling of distant galaxies through new telescopes. These once distant dreams are inching closer to reality, fueled by human ingenuity and an unyielding desire to explore. As we envision a future filled with lunar colonies, artificial stars, and even space megastructures like Dyson spheres, it becomes evident that the universe truly offers limitless potential. These events are not just about science, they are about inspiring hope, unity, and a shared ambition for progress that transcends borders. So, which of these awe-inspiring events excites you the most? Let us know in the comments below, and if this journey sparked your imagination, don't forget to like, subscribe, and hit that notification bell to stay connected as we continue to explore the wonders of the universe together. Thank you for joining, and until next time, keep looking up and dreaming beyond the stars.